Foundation. The idea behind this is, obviously the majority of people don't like science or chemistry, and we get that. I'm one of the few. It's okay. But one of the ideas behind this and why the National Science Foundation supports this is one of the thoughts is that, well, people don't really like science because they don't think it's interesting or they don't think it's cool for a variety of reasons. One of those reasons could be kind of the archetypal image of the mad scientist with like the crazy hair that Einstein popularized, the hairy chest, the lab coats. They wear. I've got it too. It's okay. They got the thick glasses. Whatever it is. Or maybe they just or science is gross, or it's for nerds. Whatever. There's all kinds of reasons why people aren't interested in science. And in some cases, this might also stem from maybe parents who weren't interested in science, and so they don't get their children interested in science. And so the idea is to have a program where we could start to target kids at a much younger level and let them know that science can be fun or it can be cool. It doesn't always have to be the equations on the board, right? The balancing the equations. It's not always the fun part about chemistry. It's an important part of chemistry, right? You need to know that stuff. But if you struggle through some of that stuff that maybe isn't as exciting, you can do some other chemistry or other science, be it biology, physics, what have you. That is fun. And so this program is designed to try and target students of multiple ages. We go to the Children's Museum because we want to get them when they're young and let them know that science can be cool from a very young age. And the students that you'll see at the museum are going to range in age from pretty young, maybe even as young as like 3 years old, on up, so very young. So they're not going to really be able to understand much. They're just going to have to go with the wow factor, so something that changes color or slime, something like that they go, wow, that's cool. That's about all you can do for them, but that's okay because we're just trying to get them, excited or interested in it. The age range will probably go up to maybe almost 4th or 5th grade, so 8, 9, 10 years old at the oldest. Some of these, there will be fewer of those kids, but they're the ones that are going to kind of want to get hands-on. They might talk your ear off. So whatever station you decide to do, make sure you kind of understand. You don't have to be an expert in it, but be able to talk to them about it, kind of explain what's going on. The slime, I saw that. I'll keep going back to that one because that's one we were already planning on doing, so I think that's great that that's up there. You don't have to get too scientific, but you can explain to them. All right, the glue is what we call a polymer, but it's a very thin polymer. You add borax to it, that cross-links the polymer and makes it stronger. You can talk about, explain like a rope versus a net, okay, different types of properties. We'll also have some pictures and stuff that I'll probably make to kind of help you out, okay? But the idea is to really get these kids at a young age interested in science. Where you guys come in is also part of the goal. A lot of high school students also still aren't very excited in science, okay? So you are also part of my target audience. The idea is to get you guys more exposure to science other than just what you're learning in the classroom and giving back to the community by trying to teach students. You don't truly learn science until you have to teach it. I promise you that. I thought I was very good at chemistry. Found out how much I did not know when I stepped foot in the classroom to teach it for the first time, okay? But yeah, so that's part of the idea also is to get you guys engaged. The biggest thing that I want to stress is, and because this counts as part of credit for your class here with Mr. Anderson, we really want you to take it on as a project, right? Feel free to have fun and be creative and come up with your own idea. Here's the key though. These kids are little. We want it to be relatively safe. So the idea is we really shoot to do experiments that are as using as many household items as possible. Not only do we want to teach them that, but we want them to be. We also want to educate their parents that are there, so their parents can go back and later on be like, "Man, that slime was really cool. Can we make slime this weekend, Mom or Dad?" And then so they know how to do that, right? They know that they can go to the grocery store and buy some Elmer's glue and some borax. If their kid gets a little in their mouth, it's not going to kill them. They might have an upset stomach. It doesn't taste that good, but it's going to be safe. So we do acid-base labs also. We teach them about acids and bases. We use red cabbage juice, which is a natural indicator for both acid and basic pHs. Okay, so things like that. So I really want you to be as creative as possible, but just try and keep it as safe as possible also. And the other thing too is, in addition to teaching them, for some of the older kids that are there, we want them to be as hands-on as possible. So we let the kids do the experiment if they can. Some of them are a little too young, and you got to kind of help them with it, you know. So do that. Be prepared to do that. But for some of the older ones, you know, let them get in there and start doing it. And you know, if they mess a little something up, and maybe the experiment doesn't go exactly, you know, as it's planned to, maybe kind of explain what's going on to them if you know what's going on. So, I mean, that's really kind of the goal. I have some pictures and stuff that I can show you in a little bit, but at this point I kind of wanted to maybe open it up to if you had any questions for me, or maybe here's some suggestions that you might have, and we can bounce some ideas back and forth. Don't be shy.
It's the quietest I've ever seen them, any of them, all of them, ever.
Yeah. This is what happens with my class after I lecture OChem for an hour,
really?
So.
Yeah. Well, we're just telling Dr. Hudnall that we're doing organic right now too. That's what he teaches all semester. So it's interesting connection there.
So would experiments involving dry ice be considered unsafe?
Dry ice is okay. We're not going to want to let the kids handle the dry ice. But if there's other parts of it that they can set up, maybe you can let them do that and just explain to them, okay, this is dry ice, right? It's solid carbon dioxide, which also turns into a gas. That's what you're seeing. And I'm going to add this in here, and something's going to happen. Okay? But yeah, that's fine. That's fine.
How many, do you know how many times we'd be like doing the experiment? Like how much stuff do we need for
That's an excellent question. It's kind of hard to tell. That's the other thing that's nice about doing it with household items. Yeah. You need to buy a lot. And you don't necessarily have to buy it. The reason I wanted to meet right away, like I said, this is supported by the National Science Foundation. So we have money to buy stuff, but if you let me know what it is, we need to have plenty of time to buy it. But if you let me know what it is, recipes and stuff like that, I can make sure we have plenty of it. So some of the things you don't need much, like for the acid-base labs, we made 1 liter of red cabbage juice, and that lasted, all day. And then we had some vinegar that we used, and we had some baking soda solutions.
Most of that stuff's pretty cheap.
Yeah.
We're going to do definitely an acid-base indicator lab, we were going to bring some pH paper too, and I know that's not as safe, but we've got a bunch that we can bring. Or if you could buy some.
The pH, we could do either or. We can buy some. The pH paper, I think we had some last time also. Okay. It wasn't too bad. The other thing that and I'll show you pictures in a minute. So when we first started this, and we're going to try to do it, but we won't. Not all of the stations will be set up this way. So I do a lot of chemistry that involves very air-sensitive compounds, especially in Texas with high humidity. You can't have the compounds out in the air; they decompose. So we do all of our chemistry in what's called a glove box or a dry box. It's a big fancy box that is filled with either nitrogen or argon to keep everything safe. So we actually made miniature glove boxes for the kids to do experiments in out of basically plastic Tupperware containers, and they would wear kitchen gloves so they could kind of act like they were doing it. We will still have some of the stations like that, but not all of them have to be like that, because what happens is you get a huge bottleneck in kids waiting in line, and it just slowed things down. We still want to have some of them like that. The pH lab, so these are just some ideas. You can, and you guys are all internet savvy. I know you grew up with it, so you can Google your heart's content. We did a crime scene investigation lab, a CSI lab, last time, and it was basically a pH lab. There was an unknown solid that the kids had to analyze. They had to figure out what it was. So they had an unknown solid, and they had a list of known solids, and they would mix them with various liquids. And so the unknown solid was baking soda, and they tested salt and sugar and cornstarch and baking soda, and then they tested those among a variety of liquids, so water, I think rubbing alcohol, and then vinegar. And of course, you add the vinegar to the baking soda. It's very obvious what happens, and so they're able to learn some stuff also. They learn that chemistry is not only fun, it's also useful. We were thinking about changing that from that type of experiment to still an acid-base experiment where they get a color change instead. But yeah, so like I said, things like that. keep it fun. I think you were going to have a question. Yeah, sorry.
I was going to, do we have to tell you our project today? Or?
No.
Okay.
No, but keep in mind that the time frame's a little short. I mean, when we did this last time, we're actually quite good at making the most out of our time. We organized the last one, which was last year, in a week. We bought all the stuff. I made all the little mock stations in a week. I would prefer to not have just 1 week this time, so maybe next week, guys, if we could do that. That's going to help me out a little bit, but we have some leeway on that.
Yeah.
Are we just gonna tell Mr. Anderson like what we need, or are you coming back?
You put it in a list and kind of, set a rudimentary list of ingredients that you need. So like we'll have what you're going to do, a little explanation, and then the ingredients you'll have, and we'll develop that and I'll email it to him, and I'll try to do that by mid next week. So that gives us kind of the rest of this week, and then up until Wednesday to turn it in, and then I'll shoot it to him, and that way he can buy the stuff.
Yeah, and that's plenty of time. And even if you're just a little bit late, that's okay. I just, because we are expanding it a little bit this year, because we had far fewer stations last time since we didn't have you guys involved yet. We just want to make sure that we're not trying to do too much last minute. We'll make it work regardless, but let's try and give it, it's going to help you guys out, it's going to help me out, okay? So.
I'll expand the group a little. I was kind of thinking no bigger than 2, but I'm thinking, if you have something where you're gearing around very young kids, if there's 3 or 4 of you, then you would be able to go one-on-one with each of the kids that come up. So I'd say no bigger than 4, and really 2 is a good target. If there's something where you really think it's going to be a lot of hands-on and you need somebody watching each person, 4 wouldn't be outlandish. So.
Sure, yeah.
And any science, doesn't have to be chemistry. It can be physics, biology.
It can be physics. So what we try and do, the reason we're definitely doing slime is what we try and do for each of these is we try and give the kids a take-home experiment. They can make something and take it home. Yeah. And so we're doing the slime this time. So we're actually going to have them mix the 2 separate liquids for the slime, pick whatever food coloring they want to color the slime, and then we're going to have them mix it in a little Ziploc bag.
So
they can take
do we still do that one, or is that like?
You can do that one.
Okay,
that's fine.
Oh yeah.
If that's yours, you can do it. That's absolutely fine.
And there's a couple of types of slime. We have one with polyvinyl alcohol too. That's even a little better slime. It's not one they would do at home, but the glue one is really good because they can do that at home, and they can do it like you said. Dad, can I do that this weekend? That was fun. So those are the ones that we really like to do. Some other things, just to throw them out, some of these are chemistry related, have a whole bunch of these little conductivity testers that light up from 0 to 10. And so like pure water, y'all remember how I did that demo where I put it in and it didn't glow, and then I poured the salt in and it glowed. So we've got that kind of small scale. That would be good for 4th and 5th graders.
Yeah, things like that would be neat. Even some of the younger kids who maybe can't understand the science, it's still going to give them the wow factor. I forget exactly how to do this. I don't ever do electrochemistry anymore. But the one where you run a light bulb off like a lemon, off some citrus fruit. Right?
Somebody like wants to do that. We could set that up. We need to get some lemons, little copper strips. The other one was plating. Involves some things that are a little bit dangerous. We would have to definitely watch, totally the whole time. Yeah. But giving them a dime, I get a roll of dimes. We could put a dime in, 2 minutes it plates, and it's copper plated. That would be cool that they could see how that works.
One's pretty neat too. Yeah. So things like that are really great. One of them we did last year. The kids loved this one. It just took way too long. We did a chromatography experiment. Does anybody know what chromatography is? Have you learned that, right?
Yeah, we did that.
Okay, good. So we did the chromatography of black ink. I didn't remember when. I don't remember when I learned chromatography. Maybe I learned it in your class.
No, you did. We did it. We did it with the little red and green pen, red and blue pens, and we did that paper chromatography.
Yeah, so we did the paper chromatography of black ink, and so we tried to treat that like a true experiment. So the kids came up, and we showed them a picture of the visible spectrum of light, and so you see all the colors, right? But black is not on that visible spectrum, and so we showed them a couple of different markers. So they have the green marker and the red marker, and then the black marker. And so we asked them, okay, so black's a color, but it's not on this spectrum. So we'll give you a hint. There are 1 or more of these colors mixed together to make black. Which colors do you think do that? And we had them fill out a little sheet first, and then they did the chromatography, right? Black is a combination of all of the visible spectrum. The problem with that is to get all of the colors to separate.
Takes a while. Yeah.
It took a while. So we kind of want to change that up this year. They were getting a little bored.
Yeah, we could do something with just like red and blue, because those things separate in about 5 minutes.
Yeah, yeah. So things like that. The other one, I think you had this in the email, but we haven't done this before, but we have the glassware to do it, where I think it would be neat, is to do some type of a density column.
Yeah.
Where what would be neat is if we could get at least 3 things, but like 3 or 4 things with different densities that you could also dye.
Like this one behind you there. There's one there that.
Yeah, yeah. So water's nice, right? Water will take any food coloring. Oil won't. But there are some relatively non-toxic organic dyes that you can color oil with. And so, we actually have we have what's called, we actually use it for column chromatography, but it's a long, thin column, and it's got a little spigot valve at the bottom. And so what we could do is we could have one set up ahead of time for the kids to see, and then we can drain the bottom layer off, so we could just drain them all, and then we can tell the kids, add them in any order you want, and it should phase separate. And so things like that are neat, but keep the colors, keep in mind they're young, so we got to make it interesting for them. I'm trying to think of what else. I thought the density column was really neat. We hadn't thought about that last time.
Yeah, now there are like 5 or 6 others that I was thinking of, but I kind of wanted these guys to think of what they wanted to do.
Sure, yeah.
If you hit a wall, then let me know, because I've got about 4 or 5 others I think would be really good. Somebody mentioned the quicksand with the starch, the corn starch. That one's kind of neat, and especially for younger kids. So.
Oh, yeah, and so that has some chemistry involved, but that really is more like a physics type problem, right? That's same thing with silly putty. They're technically polymers, but they're from a physics point of view, they're classified as non-Newtonian fluids or liquids because, right, they don't necessarily obey Newtonian physics in terms of their properties. And we essentially did something like that the last time for their take-home. We didn't do something quite as messy, but we had them make thin nanofilms using just clear nail polish. So the ladies out there, you probably have clear nail polish. You can do this at home. It's a lot of fun. Take a bowl of water, get a piece of cardboard, construction paper, something, decorate it, put it under the water, put 1 drop of nail polish on the surface of the water. Nail polish is an acrylate monomer, which polymerizes in the presence of moisture. So it polymerizes, but it polymerizes into a very thin film. Kind of looks like, have you guys ever seen gasoline on the street, how it shimmers various different colors? Or does that, yes? So it basically does this with the film, but whenever the item that's submerged under water, when you pick it up, that coating of the nail polish will coat it and create that film on it, so now you have an iridescent object. We had them design book covers, or bookmarks is what we did. So things like that. That's really more of a physics phenomenon, though, because you're getting refractions of light based on the thinness of this polymer film. So it's open to anything. Chemistry, maybe not biology. That's a little tough.
Yeah, that'd be a reach. It's for that age kid. It's,
but physics is cool. The chemistry's cool. Math is a reach.
Yeah.
Yeah. So yeah, any other questions? I'm excited to have you guys out there. Hopefully you have fun with it too. You may be famous. The Herald Zeitung covered it in an article last time we did it.
Well, we'll make sure they know about it again, just to make sure that they get there. Great. Sounds good.
Be careful what you say around the Herald Zeitung. You might get a stupid quote in there. I know I did.
Yeah.
Watch out.
What did you get?
Huh?
What did you get?
I was actually manning the. It wasn't a direct. It was a direct quote, but I wasn't being interviewed. I was just working with one of the children on the crime scene lab, and I had them mixing the various things. And I think it was probably. I forget which solid they were testing, but I think it was the cornstarch and like alcohol, and so those don't mix at all. The cornstarch just settles to the bottom, and I had the kid mix it, and I said, "So what happened?" Because this is a really little kid. I was like, "Nothing. That's really boring, right?" And they totally quoted me as saying, "Really boring." It's like that's not,
wow,
not what we were trying to do.
Let's see if we could stir up some controversy here.
Yeah.
Texas State professor says that science is boring.
Yeah, so not what I was trying to do, but then they followed it up with, when they did the actual experiment, they said, but when they mixed the baking soda and vinegar, an experiment did happen.
Yeah, it was exciting. Yeah. Well, at least you weren't on CNN. Questions? Anybody? know y'all got places to be, but thanks for coming in. Make sure you signed in. By Wednesday, I need what you're doing pretty specifically, paragraph about it, ingredients. Turn it in to me by your class Wednesday, and then I'll shoot that up to them and you can buy the ingredients. That way y'all don't have to purchase them.
Sounds good. Have fun with it, guys. Really, the kids do. They have a great time with it.
All right, grab another cookie for the road.
Mr. Anderson.
Bye-bye.
Hey, Julian, I'll text you about.
Sure.